Right. Hi everyone, how are you? So today we're gonna continue with the algebra, right? So welcome back, all of you. Yeah. So last we completed the topic of algebra, right? And now we're gonna continue off with the new topic that we began in the last class, which was um, which was geometry, right? So I told you guys the number of topics that we're going to cover in geometry. So it's going to be the properties of 2D and 3D shapes, right? There's going to be angles, lines, and how to find angles in different polygons, right? Now then there's going to be Pythagoras theorem. So this is where we began off. Last time we discussed, okay, so this is our topic for today, geometry, right? So right, so this is what we started in the last class, right? So we have successfully completed the Pythagoras theorem. All right, so Pythagoras theorem, just a quick review. So can anyone remind the whole class, so whoever's online, so can anyone remind us what we studied about Pythagoras theorem, right? It's a special type of theorem that allows us to find what exactly and where is it used and why is it used. The most important thing is why is it used. All right, so this is what we studied. So is there anyone in the live that can remind the whole group of people like what it was and what we did? Does anyone remember? Yeah, right. So Pythagoras theorem was a special type of theorem that was specifically designed for right right angle triangles, right? So it was a special type of theorem that was designed for right angle triangles. So what are right angle triangles? Right, so right angle triangles are triangles that have one side which is 90 degrees. Okay, so Pythagoras theorem is basically a theorem which is devised to find out any length, which is, if we are given any two lengths, so it could be used to find out any other length, right? So let's say this side is going to be called hypotenuse, right? This is what we studied. Then this side is going to be base, and this side is going to be perpendicular, right? So we studied that hypotenuse square is equals to base square plus perpendicular square, right? So this is the theorem. If we have any one missing value, so we're given two sides and one missing value, so we can apply this equation and find out the missing length, right? So let's do a quick example, right? So now here is an example. So this is a 90 degree, and now this longest side is called the hypotenuse, which is exactly opposite to 90 degrees. So this side is 5 and this side is 4. So we need to find this length. How do we do this? So the equation says that hypotenuse square is equals to base square, right, plus perpendicular square, right? So which values are known to us? So hypotenuse is known to us, so it's going to be 5, right? So 5 square equals to base is known to us, which is 4, so 4 square, right, plus perpendicular. So what's the value of perpendicular? It's x, so x square, right? So now I need someone to answer me very quickly, right? I'll just wait here for approximately 30-40 seconds. Now, is there anyone who can answer me what's going to be the value of x? Quickly, it's a pretty easy equation. There's nothing. There's nothing too difficult in it, right? So yeah, now it's going to be 25, right, equals to 4 square is 16 plus x square, right? So 16 is going to go to the other side. It's going to be 25 minus 16, right? And we're going to be left with x square. So x square is equivalent to 25 minus 16, which is 9, right? So take a square root on both the sides. Now square and square root cuts down, and then we're going to be left with x. Now root of 9 is going to be 3. So we found that this length is actually equals to 3, right? So this is how we can use Pythagoras theorem to solve the length of any, to find out the length of any one side if we are given with two other lengths, specifically in right angle triangle. So this is very important. It is only utilized when there is a right angle triangle. It can't be applied to any other type of triangles. That takes us to our next topic, which is properties of 2D and 3D shapes. Okay, right. So now, okay, so this might sound a little bit something that we've been studying since our whole life, since kindergarten. Like we know a lot of space, we know a lot of shapes, we know how to solve them. So yeah, I'm not gonna teach you the basics. Okay, if you want me to, I can start off with the really basic things. But I think we're all familiar with how many sides a triangle has and everything like that. So we are familiar with that. So I'm going to take you up a notch and explain you the basic concept between what's a 3D figure and what's a 4D figure. Oh, whoa, what's a 3D figure and what's a 2D figure? All right. And what can we find? All right. So let's talk about a 2D figure first. So which figures do you think is counted as 2D? What does it mean when we say 2D? Does anyone know what does it mean when I say 2D? What does it really mean? So anyone with the correct answer can comment down below, right? Yeah. So what is it? What's a 2D figure? So 2D figure is something that has that does not have a width. Okay, does not have the thickness, right? So a piece of paper, a very thin slice of piece of paper, imagine a pile of bundle of papers. Now imagine a single layer of paper. Okay, so that basically, okay, so we can hold the paper, right? But in 2D figures we can't hold anything because it does not really have the width. It does not really have the width, right? So if I draw a square in front of you like this, okay, so we can't really hold a square, right? Because it does not have anything to hold, right? It does not have the thickness for holding it. It just have two dimensions. Okay, so which two dimension does it has? So it has length and it has breadth, right? But ironically, its breadth is also of an equal sign, equal length as the all right. So let's talk about squares first. Okay, so it has length and the other side, because it has one length over here, so all the sides are equal. So how do we indicate if all the sides are equal? So we write this dash down. This indicates that all the sides are equal. So this means if this length is L, then this length is L as well, and this length is going to be L as well, and this length is going to be L as well. So in 2D figures, we are aiming to find out two important factors. So what two important factors are those? So we are aiming to find out the area of a 2D figure, and we can find out the perimeter of a 2D figure. So can anyone tell me the difference between the two? What's the difference between area and the perimeter? So what's the difference between an area and the perimeter. Go on, come on, guys. Um, okay. So area basically indicates that how much surface a 2D figure has covered, right? Right. If I place a square over any particular surface, how much region does it occupy? Okay. So now, what does it mean when I say what's a perimeter? So a perimeter is the boundary, is the length of the boundary of any shape. Okay. So how many types of shape are there in our GCSE exams? Okay. So I'm gonna continue off with, okay, so there are triangles. First, there are triangles. Okay. So we know how many different type of triangles are there. So there are basically three different types of triangles. Okay. So one triangle, right? So how many different type of triangles are there? So one triangle is called scalene triangle, right? Which one is called scalene triangle? So what does an scalene triangle means? A scalene triangle means that it none of its sides are going to be equal. Okay. None of its sides are going to be equal. Let's say this side is 13, this side is um, or just light in terms of variables. So this side is x, this side is y, and this side is z, right? And the angles are going to be different as well. So all the angles are not same; they're all different. Okay, so all lengths, lengths and angles are different. Yeah. So now, if I talk about another type of triangle, it's called isosceles triangle. So why am I explaining you these? Because in terms of angles and in terms of everything else, is going to play a major role. So you need to know what does that mean. Okay. So in terms of scalene triangle, it's a triangle where any two sides are equal. Okay. So let's say that these two sides are equal. This means if this length is x, then this length is going to be x as well. Similarly, these two angles, okay, so these two angles are going to be the same as well. So the opposite angles to the same similar sides are going to be equal as well, right? So this is the property of scalene triangle, oh, isosceles triangle. Now comes another type of triangle which is very common, right? It's called equilateral triangle. Okay, it's called equilateral triangle. So what's an equilateral triangle? So equilateral triangle is triangle which has all the lengths equal, right? So let's say that this is an equilateral triangle. This has all the lengths of the equilateral triangle are equal, as well as the angles. All the angles are going to be 60. So this angle is going to be 60, this angle is going to be 60, and this angle is going to be 60 as well, right? Now, there's a fourth type of triangle that we discussed here. Okay, so this type of triangle is called right angle triangle. What is it called? Right angle triangle, right? So, in terms of right angle triangle, as I just explained to you earlier as well, triangle. So, as explained to you earlier as well, so one it has all the lengths of it. It's not necessary that all the lengths of the sides are definitely have to be different, so any two sides could be equal. However, the one identifying factor is that it has one side which is 90 degrees, right? So and this is called a right angle triangle, right? So these are the differentials. Now, there's another shape. right? So first let's just complete triangles. So in terms of triangles, there are two formulas to find out the area of a triangle. Okay, so to find out the area of a triangle, we have two formulas. One formula is area equals to half multiplied by the base multiplied by the height, right? So what does it mean? So let's say if I have a triangle like this. Okay, so there's a height. What does a height mean? So height is any length which forms 90-degree with the base. Okay, so height here means a length. Height here means a length that forms 90 degrees with the base, right? So right, so how do we identify if there's a 90-degree with the base? So first identification is there's going to be this square box. This shows that it's going to be a 90-degree, right? Now what does a base indicate? Base indicates the place where the 90-degree lies upon. Okay, so now let's take this height as 10 and let's take this whole base as 4. Okay, so now what's the area of this triangle is going to be half times base, which is 4, times height, which is 10, right? So 2 times 1 is 2, 2 times 2 is 4, so 2 times 10 is 20. So that's going to be our area. Okay, so it's pretty simple, right? Now let's say if it is 4 centimeter and 10 centimeters, so the area is going to be centimeter square. So it's the units are very important in terms of area. And now we're going to study volumes ahead. In terms of 3D figures, they're going to be cubes, so it's very important to write down the area. So the lengths are going to be, because this is centimeters, centimeter times centimeter is going to be centimeter square. That's why the unit is centimeter square, right? I hope this is very clear to you. Now let's move on to the other formula, right? So I told you that there's going to be two formulas for areas, right? So the second formula is to find out using angles. So it's going to be area equals to 1 over 2 a times b times sine c. So what does that mean? Okay, so it means that you now have a triangle where one length is a and the other length is b, and the other length is c, right? So the opposite side of a represent an angle a, the opposite side of b represents an angle b, right? And an opposite side of c represents an angle c, right? So it means that in order to find out the area, we need two consecutive sides. Okay, so let's take a and b, right? So it's going to be 1 over 2 times a times b, right? And then an inclusive angle between them, so it's going to be sine c. So this is one of the major formulas that I don't think a lot of people teaches, but it comes in very handy when you do not have enough knowledge about the question, right? So let's take some examples. Okay, so this is 4 and now this is 5, and now this one here, right here, is going to be 40, right? Or maybe 30. Let's take 30, right? Now what are we going to do? How are we going to find um the area of this triangle? We do not have a height, we do not have a base. If we consider this side as a base, we still don't have a height. So how do we really find out the value of a height, right? Or how do we find out the value of the area? Now what we do in this case is going to be utilizing this formula. All right, so we know that these are two sides and this is an inclusive angle between them, so we write it down as 4 times 1 over 2 times a times b, which is 4 times 5, and then multiply it with sine c. So sine c means the angle inclusive between the two lengths, right? So it could be sine 30, right? So now let's solve it. So 2 times 1 is 2, 2 times 2 is 4, right? So now 10 times sine 30, right? So is there anyone who can give me the answer of sine 30, right? So it's going to be 10 times. Okay, so the angle, remember that the angle is in degrees, so don't forget to turn your calculator into degrees, right? So sine 30 is going to be 5, right? So the value of sine 30 is 1 over 2, so 10 times 1 over 2 is going to be 5, right? So this is going to be the area, and this one is in centimeters, so the length is in centimeters, so it's going to be centimeter square. So area is equals to 5 centimeters square. So I hope this is understood by now, right? I hope that this is very clear to all of you, right? Now let's move on to another topic, to another thing which I discussed. So in terms of 2D figures, we're going to learn two things, right? One is area and the other one is perimeter. So perimeter for any shape is pretty easy. So now in terms of perimeter, we're going to say that if we have to find out the perimeter of any shape, perimeter of for any shape, what we're going to do is we're going to add the lengths of all the sides. So what does the perimeter mean? Perimeter means that the length, the boundaries, the length of the boundaries is called a perimeter, right? So let's say that this length is A, this length is B, this length is C. So perimeter is going to be very easy to find out. It's going to be sum of all sides, right? So this is the formula which is going to be common for each shape. Okay, so for every shape, this formula is going to be there. Okay, so when we add all the sides together, it's going to be equivalent to the perimeter of the shape, right? So we have A, B and C, so we add them all, A plus B plus C, hence we're going to get the perimeter. I hope this is very clear to all of you, right? Now let's move on to now that we've covered up triangles, right? So it's time for some other shapes. Now the second shape is going to be quadrilaterals. So what does a quadrilateral mean? Does anyone know what does a quadrilateral mean? So what's a quadrilateral? Okay, so my charts are still loading, right? So I hope to get a response from you guys, right? So what's a quadrilateral? So quadrilateral is basically any shape with four sides. Quadrilateral is what? Quadrilateral is any, right? So it's a shape with four sides. A shape with four sides. So that's the definition of quadrilateral, right? So why I'm telling you this, because most of the questions are going to be mentioning quadrilateral and not the exact name of the shape, right? So it's very important that you know. So which shapes are included in quadrilateral? So there's a square, right? So can you name a few shapes which are included in quadrilateral? So there's rectangle, right? Then there's rhombus. Can you name another one? So there's also parallelogram. Then there's trapezium as well, right? Right. So these are all the shapes. Perfect. So a lot of you know this. So I'm really glad to see this. Right. So a lot of you know this. I'm really glad. Okay. So now, there's gonna be not much different in terms of explaining them. So I'm gonna go over all of them very quickly, right? So what's a square? A square, like I explained, it's a box, right? And all the lengths of a square are equal. So if I say that one length is L, that means all the lengths are L, right? So what's the area for a square? So area can be found out by length times length, right? So we could write it as L square. So that's the area for, that's the formula for the area of a square, right? Now in terms of perimeter, what we're gonna do, we're gonna add all of the sides. So it only has like four sides, and we know the length of all the four sides, so the perimeter is easy to find. So I can, either I can add all of them, L plus L plus L plus L, right? Or it could be 4L, right? So a simplified form is just multiply one length with 4 and you're going to get your perimeter. Okay, I hope this is clear. So this is pretty much what we've been doing since our um, like early stages as well. Now let's move on to what's rectangle. So rectangle is essentially a shape which has one side which is longer than the other one, right? So this length, this is called a length, and then this is called a breadth, right? It could be called a breadth, it could be also called a width. So anything that you like, it could be called that, right? So now in terms of area, we can write it down as length times breadth, right? So now in terms of perimeter, what does it mean? So opposite sides are equal in the ideal thing. Okay, so one thing I missed over here, so the corners are 90 degree. In square the corners are 90 degree, right? And in rectangle the corners are also 90 degree, right? So one thing that that shows is, if I'm gonna add all the angles of a quadrilateral, so the sum of angles, so the sum of angles for a quadrilateral is always going to be 360, right? So add like multiply 90 by 4 and you're going to get 360, right? So that's the sum of angles, right? Now let's move on to rectangles. So all opposites, opposite sides are equal. So this, if this is L, then this is going to be L as well, and if this is breadth, then this is going to be breadth as well, right? So we could write it as 2 length plus 2 breadth. So somebody answered it right in the comments. Great job. Now let's talk about rhombus. Okay, so what does a rhombus means, right? And how do we actually calculate it? So what does rhombus mean and how do we actually calculate it? So rhombus is essentially a shape which is ideal, which is identical or similar to a square. However, it is a little bit tilted. Okay, it is a little bit tilted. So it, like a square, it has all the sides which are equal to each other, right? So it has length times length times length and length, right? But the angles are not 90, they're different. Okay, so they're not same. So the opposite angles in a rhombus are equal. So this angle is equals to this one, and this one is equals to this one. So that's the property in rhombus. So this is what you need to understand. Okay. Okay, so I might have made a mistake. My screen might have closed down, so let me just share it again. Okay, so yeah, is my, yeah, my screen is visible again, right? So now I was talking about rhombus earlier. So rhombus is essentially the same as a square, but it's a little bit tilted. So now how do we find out the area for a rhombus, right? So how do we find out the area for a rhombus? Let's take a clear image of a rhombus. Okay, like this, right? And now what we're going to do is we're going to find out the area for a rhombus. So this is essentially L, right? Now the area for a rhombus is L times H. So what does an H means, right? So this area is, all of these lengths are L because all of these lengths are equal, right? So what is L? With what is H? So H is the height. H is the perpendicular height of a rhombus. So it's a line drawn, right, from top to the bottom, which makes 90-degree at the bottom. So that's H, right? So how do we find out the area for a rhombus? We find out the area for a rhombus by multiplying its length by its height. So that's how we find out the area of of a rhombus, right? Now, how do we calculate the parameter? So parameter is going to be pretty much the same. So it's going to be 4 times L. Like I told you, it's going to be the sum of all the lengths. So if all the lengths are L, right, so it's going to be 4 times L. Now, who's going to tell me about parallelogram? So what does it mean when I say it's a parallelogram? All right, I'm waiting, guys. Hurry up. Yeah, so parallelogram looks something like this. Okay, so it's basically a rectangle but a tilted one, right? Just like a rectangle, just like a rhombus was a tilted version, just like a rhombus was a tilted version of a square. Now it's a tilted version of a rectangle, right? However, in rectangle, all the angles were 90 degrees. Here, the opposite angles are equal, right? But they're not equals to 90, right? They could be any angle but 90, right? Another aspect of it is that it has length and the opposite sides are equal, obviously, which was the rule. So this is going to be length as well. If this is breadth, then this is going to be breadth as well, right? So these are some of the properties. Now let's talk about what's the formula for the area of a parallelogram, right? So it's gonna be the same as the area for a rhombus. So it's gonna be length times h. So I've written down breadth. I've not written down h. So what's h? H is exactly what we discussed in rhombus. So it's gonna be a vertical perpendicular line which is drawn from top to bottom. It's gonna make 90-degree with the base, right? And this length is gonna be called h. It's a perpendicular height. That's why we're gonna multiply our length, our breadth, right? So not our length, right? We're gonna multiply our breadth with h, right? So the base at which the height goes down to, that length multiplied by the height. Okay, so if I draw a height this way, if I draw a height this way, then it's going to be length times height. Okay, and this is going to be the height. You understand this? So this is very important. Now, what's going to be the perimeter? So perimeter is going to be the exactly the same as rectangle. So it's going to be 2b plus 2l, right? So I hope you understand this now. So this was pretty much what we already knew. Now, most of you don't know what a trapezium is. So in my experience, a lot of you struggle with trapezium. So what does a trapezium mean? What does it mean when I say trapezium? What does it mean when I say trapezium? Okay, so trapezium is essentially a shape which has two parallel lines. Okay, so it has two parallel lines, and that's it. So it could be drawn like this, right? So that's the identification of trapezium. It just has two parallel lines. Okay, it could be also a version of a trapezium is like this. Okay, so it could be represented as any way. And how do I show that it has two parallel lines or an adjacent lines? So it is indicated by this arrow. So the two lines which has arrow upon them is is going to be the parallel lines, are going to be the parallel lines, right? So I hope this is clear. So let's take this side as A, and let's take this side as B, right? So, and if it has a 90 degrees, so let's take this side as a height. Okay, so the formula for an area is going to be 1 over, okay, so the area of trapezium is going to be 1 over 2 multiplied by the sum of parallel lines, sum of parallel lines, right? Parallel lines, right? And then multiplied by the height. Okay, so in this shape it's going to be area equals to 1 over 2 a plus b multiplied by h. Why h? Because this is going to be the vertical height, right? And now what about this shape? So this has a and b, it doesn't have a height, so we need to find the height for this shape, right? So this is going to be the vertical height, which makes 90 degree with the base. So the area for this is going to be the exact same as this one, right? So we're going to take two lengths a and b, and then we're going to add them together, divide by 2, and then multiply it with the vertical height. Kudos, so somebody actually answered it right. Perfect. Now what about the perimeter of, trapezium? So the perimeter is going to be the sum of all sides. So let's take this slant side as c, right? So we need to add all the sides together in order to find sum of all sides, right? So this is gonna be the perimeter of trapezium, right? So now, as we've completed this. Now we're gonna move on to another portion, right? So we've done quadrilaterals, we've done triangles. Now let's move on to the most asked question now. So it's going to be the third segment, which is going to be circle. Okay, so here I'm going to cover circles. Okay, so all about circles. So here I'm going to cover circles, right? So basic circles, and then I'm going to cover semicircles, right? So what semicircle is, and I'm also going to cover sector over here. So what does a sector mean, right? So these two are one of the most asked questions in terms of mensuration, and at least you can expect around 6 marks of your exam, GCSE exams, coming from solely just sectors or circles. All right, so let's talk about a circle. Circle is something like this, right? Now circle has a center, right? Now any length which goes straight from the circle and touches the circumference, right? What's the circumference? Circumference is the boundary of a circle, right? So the length that goes from the center and touches the circumference is called a radius, right? And now if a line crosses from one end of the circumference to another end of the circumference while crossing the center of the circle, right, that line is called a diameter. That line is called a diameter, right? So here by that we can indicate, that diameter is equals to 2 radius, 2 times the radius. Okay, so here's one radius and here's another radius. So add the two radius together and you're gonna get the diameter. Okay, now let's talk about how to find out the area for the circle. Okay, so this is something that we've studied a lot of times. So area for a circle is gonna be pretty simple. So if any one of you does not understand anything, kindly let me know in the comments and be a little bit more specific because I've covered a lot, right? So which part or which thing do you not understand, right? So in terms of area, the formula is going to be pi multiplied by r square. Okay, so pi is a irrational number which has a value of 3.142, or it could be written as 22 divided by 7. Okay, so these are the two values which could be used for pi. Okay, so or in case when you are allowed calculator, so there's a key for pi specifically in the calculator, right? So and now in terms of perimeter, so a circle does not really have a perimeter. Okay, instead of a perimeter it has another property which is called circumference. Okay, it's called circumference. Okay, so that means the boundary of a circle. Okay, so how do we calculate the boundary of a circle? It has a pretty simple formula. So there are two simple formulas for circle. So one formula is gonna be 2 pi r, right? And the other formula for the circumference is gonna be, now 2 pi is equivalent to what we've discussed. 2 pi is equivalent to diameter, right? So we could write it as pi times diameter as well. So here are the two formulas finding out for finding out the circumference of a circle, right? So I hope this is clear. Now let's talk a little bit about semicircles. So semicircles, everything is gonna be exactly the half of a circle, right? So let's take this as a circle now. Let's talk about semicircles for a while now. Okay, so if I, this is the center, right? So if I divide my circle into two halves, right? So this one is called a semicircle, like the half of a circle. Okay, so it's going to be something like this. So this is the center and this is going to be the radius, right? So everything's going to be half now. So area which was pi r square for circle is going to be half pi r square, right? Now which was circumference which was um, pi r circumference which was pi r square is going to be half as well. So 2 pi r is going to be half as well. So 2 pi r divided by 2, plus it has some new features. So it has 2 times the radius as well. So it has 2r as well, right? So we're going to divide these two. So it's going to be pi r plus 2r. So circumference is going to be the length of all the sides. So this one is pi r, this one means pi r, and then it has two different lengths, two radius over here as well. So it's going to be plus 2r. I hope you all understand this. Okay, so this is a little bit about circles. Now one of the major topics is going to be sectors. So just in case I am not able to complete this sector in this lesson because it's a big topic, so we're going to continue this off on Monday, hopefully, right? So stay tuned, right? So this is the center of the circle. Now what's a sector? Okay, so a sector is basically when two radiuses are drawn in such a way that they form an angle between them. Okay, so let's take this angle as theta. Okay, so if two radiuses are formed in such a way that there's an angle theta in between them, then this forms a sector, right? So it's basically a slice of a pizza, right? So a slice of a pizza is basically nothing but a sector. All right. So a the smaller slice is gonna be minor sector, right? It's called minor sector, and a bigger slice is called a major sector. Okay, so it's called a major sector, right? So now, obviously, this one has also an angle which is 360 minus theta. All right, so the whole circle when completes is going to form a 360 degrees. Okay, so this whole forms a 360 degrees. So let's say that this angle is going to be theta, then this angle is going to be what? It's called 360 minus theta, right? Now, this length, this length over here, it has a special name. Okay, so this length over here has a special name. So what does this length, what exactly is this length called? Okay, so what exactly is this length called? It's called arc length. Okay, this length is called arc length. Perfect. Now let's come on to finding out a little bit about how to find out the area for a sector, right? So if I draw my sector outside of a circle, it's going to be something like this, right? Something like this, right? This is the center of the circle, right? And it has two radiuses over here, it has some theta over here. So we need to find out the area of this sector, right? So how are we going to do this? So area of a sector is devised with a special formula. It's called theta divided by 360 multiplied by the area of a circle. So what's the area of a circle? It's called pi r square, right? So let's suppose an example. Let's suppose I have a sector like this. Okay, so this length is something like 60. Let's take it 60, and let's take this radius as 4. Okay, so if I need to find out the area, it's going to be very simple. So it's going to be 60 divided by 360, right, multiplied by pi r square. So what's the value of r is 4, so 4 square, right? So it's going to be 60 divided by 360, which is 1 over 6, right? And now multiplied by pi, and then multiplied by 16, right? So it's going to be 8.4. So the area is 8.4, right? So this centimeter square, right? Do not forget the units. Now, um okay, so I'm gonna explain. Probably I'm not gonna be able to explain the concept of radians in this class, but I'll hopefully explain this in the next class. So whoever's online right now, please remind me in the next class to explain you the concept of radians. And okay, so the formula is going to be a little bit different when we calculate. Instead of these angles being in degrees, we're going to calculate these angles in terms of radians. So the formula is going to differ a bit. Okay, so please remind me in the next class, right? So now let's talk about the perimeter of a sector. Okay, so in terms of sector, I explained to you guys earlier that what exactly is a perimeter. Perimeter is the sum of all the sides, right? So how many sides that a perimeter has? Okay, right? So these are the three sides, right? So if this is the center of the circle, this is going to be r, this is going to be r, and this is going to be r arc length. Okay, so these are the three sides, right? So these are the three sides, r, and then arc length. right? Now, if I asked you to find out the perimeter, so it's going to be pretty simple, right? 2r plus arc length, right? Now, how do I find out the length of this arc? That is the main question, right? So in terms of perimeters, it's a pretty simple formula. It's a straightforward formula. Now, for this perimeter, I need arc length. So how am I going to find out the length of this arc? Okay, so yeah, somebody answered me right about perimeter. Now now I need an answer for arc length as well. So if I have to find out the length of the arc, how am I going to do that? Okay, so it's a pretty simple formula. It's going to be exactly the same. So this angle is going to be theta, right? So theta divided by 360 multiplied by what? Multiplied by the formula for circumference. So the formula for circumference is 2 pi r, right? So this is how you find out the length of the arc, right? So I hope everything is clear to you guys up till now. Let's do a quick question. Okay, so let's take this example only. Okay, let's take the example that we've already written. Mm, so yeah, let me just copy it here. Okay, so this is the example, right? So first we need to find out the perimeter. So perimeter says that it's going to be 2r plus arc length, right? So now, for that we need arc length. So let's find out the arc length first, right? So it's gonna be 60 divided by 360, right? Multiplied by 2 pi r. So the value of r is 4, right? So it's gonna be 60 divided by 360, right? So 60 divided by 360, right? Multiplied by 2 times pi times 4. Okay, so it's going to be 4.2, right? So the arc length is 4 times 4.2, right? So if we add it to the formula of perimeter, so it's going to be 2 times 4, right, plus 4.2. Okay, so the answer would be 2 times 4 would be 8, and then plus 4.2, it's going to be 12.2 centimeters. Okay, so this is the length of the perimeter, and this is how you find the arc length. Am I clear? Is there anyone who does not understand this? Is there anyone over here who does not understand this? So if you guys have any questions for what we've so what we've learned in terms of 2D figures up till now, do you guys have any questions, have any queries, feel free to ask me. Now is your time. I'm sorry. Now is your time. Feel free to ask me anything that you do not understand in terms of 2D figures. So what we've covered so far is pretty much the whole syllabus for 2D figures, right? So we've learned that in terms of 2D figures, the examiner can maximum ask you about the area and the perimeter. Now we've covered the most common types of shapes. All right, so let me remind you. All right, so in terms of exams, it's not necessary that you get exactly one shape. They can give you more than one shapes combined. Okay, so we're going to practice questions like that, so don't worry about it. So let's say if they give you a shape like this, okay, and if they give you a shape like this, right? And now they're asking you how to find out the area of the shape. So what you're going to do, you're going to divide the shape into two parts. So this part is going to be the semicircle, right? And then this part is going to be the rectangle. So this will come with practice. Okay, so one thing that you guys need to practice is, now you have all the formulas, you have all the information that you need in order to solve geometry questions, question in terms of area, and question in terms of uh, yeah, question in terms of parameter. So you guys have all the information that you need, right? So what you're gonna do is, you guys need to practice now, right? So we pretty much have everything that you guys need to mention. So let me just go through it quickly. So there were four types of triangles that we discussed: scalene triangles, isosceles, equilateral, and then right angle triangles. Okay, and then there's gonna be quadrilaterals. So quadrilaterals are there are five types of different quadrilaterals that I discussed with you guys. So there's the squares, right? There are rectangles, there are rhombus, and there's parallelogram, and then there's trapezium. So five different types of quadrilateral with different formulas for each one of them. So I've mentioned the formulas over here. So if you guys want to take a screenshot of it, quickly take it, right? Now, then we move on to another shape, um, which is called circles, right? So we discussed the area of a circle, we discussed the area perimeter, or what we call the circumference for a circle, right? Then we moved on to how to solve uh, the the questions of semicircles. So I discussed how would you find out the perimeter of a semicircle. So it's going to be the circumference, everything's going to be half, right? So area of the circle is going to be half for semicircle as well. Now the circumference is going to be half um, for uh, semicircle, half of circle, right? So the circumference for circle was 2 pi r. Now the circumference for semicircle is gonna be pi r. Now for perimeter, there's gonna be the sum of all sides. So there's this side which is consisting of 2 r's. So if you add them both, so that's gonna be your circumference now. Now, in terms of sector, we've talked about how to find out the area of a circle, right? And then we've also found out how to find out the perimeter of of a sector, right? So the perimeter consists of so it's basically, let me just remind you. So it's basically, as it's a ratio, okay? So it's a segment, it's a portion of this whole circle, right? So what we did nothing special. What we did, we took a ratio of this angle to the whole angle of the circle, so that we get this portion out. So that's the logic behind this formula. All right, similarly we did the same thing with the arc length as well, right? So I've gone over every topic that we've discussed so far. Now now is your time. We have approximately 1 or 2 minutes left for this live session. If you guys have any questions, any queries, feel free to ask me right now. So, do you guys have any queries? Anything that you found difficult? Anything that you did not understand? You're welcome to ask any questions. All right. So, I hope everything's clear because I'm not seeing any questions as of yet. The next class is going to be on Monday, right? So then we're going to do some of the questions related to 2D diagrams. We're going to go over to the concept of, we're going to start off with the concept of 3D figures then, and what examiners mostly ask in terms of 3D figures, right? So that's our aim for Monday. So that's it for today. So I hope you guys would take care of yourself. And yeah, that's it. All right. So take care, everyone. Goodbye. Hopefully, see you on Monday. Bye.